Now, of course, when you're doing this, the next thing I was going to talk about is index types, because Postgres has a lot of index types. And a lot of probably the examples here are just using single column indexes. But depending upon how you're pulling data, compound indexes can give you a big boost in terms of querying. So if you, like, for example, SaaS apps typically have some sort of a tenant ID or an account ID that's on almost every table. And frequently when you're querying table, assuming you have all the tenants in a single table, you're always going to be using that to pull data. So you're always going to pull by the tenant ID or account ID as well as some other value. Well, having that in a compound index or a composite index, basically a multiple column index, can give you a big performance boost. So that's one thing to consider in terms of addressing your slow queries is, are there instances where I could use a compound index that would give me a more efficient plan? Other types of indexes that you should take into account are partial indexes. And what that is you're only going to index part of the data set. So for example, if you're only, and one area I particularly like partial indexes, exactly what you were saying about a Boolean. So if you have a Boolean field, it's hard to index that. But what you can do is actually create two different partial indexes. So you have one index where that Boolean value is true and another index where that value is false, as long as you're choosing some other column, for example, in the index.
Mm-hmm.
But with that, if you are checking that the Boolean is true, it will use one of those partial indexes. If it's false, it'll use the other index. And that can give you astronomical performance gains
Mm-hmm.
because in addition to Booleans, like things I was talking about, the status fields, if you're checking the status, that's another way I like to use these partials. Now, yeah, you're going to have more than one index on a column, essentially, where the status is A and where the status is B and where the status is C. But Postgres is fine with having multiple indexes, but it can really give you a huge boost to performance because it's no longer it's a smaller index because you're only storing just part of the data, and it doesn't have to scan through that status column. It just chooses the index to use, and it's scanning everything else.
And while we're talking about indexes, let's touch real quick on why would I not just want to throw an index for every field in my column? What's the downside of that?
Well, the downside is for maintenance. So basically, every time you're going to insert data or update data, those indexes have to be updated as well, particularly if the data is going to be impacted. What you're inserting and update is going to be impacted because it's in the index. So you want to be cautious that it's going to diminish your insert, update / delete performance. Like you may get great select performance, but you're going to diminish that type of performance. And you don't want to, that's why I said at the beginning, you want to start with primary key and foreign key.
Mm-hmm.
Your primary key and your foreign keys. And then of course, I add a few more based upon how I know I'm going to be querying it. Like, is there an account ID? Should I do this as a multi-column index on the tenant, or the account ID? Or is there a date time I know I'm going to be using frequently? I'm going to change things there. But basically to start, just a primary key and a foreign key.
Right.
Because so many times you're not going to be querying all these other areas, but you could use things like PG stat statements to key you in what queries are taking the longest and what do I need to keep a lookout for.
Right. And it's important to understand how indexes work in your particular RDB because that's one of the reasons you don't want to typically index low cardinality fields, is not because it's bad to index it from a theoretical standpoint, but because it doesn't help you enough to overcome the loss of performance you get by having to update that index every time you change the record. So, understanding how those things works helps you make better decisions about which indexes you should use and when you should use compound versus single indexes and when, that kind of thing. So it's really important to understand indexing strategies in the database if you want speed improvements, because indexes, like I said, when we have a speed issue, when I'm trying to tackle a speed issue, the first thing I do is look for slow queries. And when I find them, the first thing I do in there is look for index problems. And that's usually where I can get 90% of my performance increases.
Yep. So we were talking about partial indexes. The other index, like you were talking about, hey, there's an index here, but it's not using it. I get that a lot from support requests, and a lot of times it's because you need an expression index. So in terms of Postgres, if you put in, let's say email, let's say you have in a column in a table that has an email and you have an index on that email. But when you go to query, you're saying, I'm going to ask for a function of lower of the email. So you just want to do a search through it looking for lowercase emails. Well, the problem is that's now considered an expression index and it's not going to use that index. So what you actually need to create if you're going to query this email field that way, like you're always going to be using this lower or lowercase function to query that column, you need to add an index that has that function in it. And then Postgres knows to use it. So you can't just have an index on email. You need to do an expression index on email where you're saying lowercase the email. So that's another index consideration you need to take into account. And you can see that when you do an explain analyze, why is it not using the index? Well, it's because of that. Or I've seen also cases when people are trying to do a search. So particularly a wildcard search where you're just looking for an instance of something within a text field. Indexes aren't going to really help you there. There are certain ways you can do a B-tree index such that you can say, look for maybe the first part of it, but trying to find a text string within it, it's not going to work. But then you're looking at different features like full text search, engine indexes. So these are entirely different features of Postgres that'll enable you to index this text and be able to retrieve it very quickly. So that's
gen indexes,
another thing you may run into.
Yeah, gen indexes and full text indexes are a much different animal than just data indexes like we're talking about here. It's almost like they should have named them something besides index, because it's almost a completely different thing other than conceptually it's ordering data and making it searchable.
Well, I mean, there's a lot of different indexes, rum and gist and brin and, that have all their different use cases. So, the main index is just the B tree. So that's mostly what we're talking about. But the next one you'll probably hear or use is a gen index, but there's also other index types that have their specific use cases. Like if you're doing geographical information systems, you're going to be using SPGIST or GIST, but as you get into that, you can, do some more research in that area. And I think we should kind of describe, at least for Postgres, just so people understand that there's the data tables, and that is called the heap. And that's one structure. Indexes are entirely different structures. So they can look and appear differently. So a binary tree looks very different from a gen, but it's kept independent of the heap. And a lot of times when you're querying something, you look up something in the index through this one structure. But then once you have the reference to it, you then consult the heap to pull back all the data for that row. And that's typically what you're going to do in Rails when you say you find account 123. You're going to, presumably that has a primary key. It's going to look through, find ID 123. and then it's going to pull back all the data for that row going to the heap, so that separate structure, and pulling that data over. So that's typically how things work. Another area that you can focus on for performance is trying to do index-only scans. So what that means is you're going to do a query you want to query your database, but you don't want to access the heap. So for example, if all you need is an ID from, say, the account table, then Postgres knows, hey, I just need to look in the index. I don't need to then look it up in the heap. So that gives you a more immediate result. You just immediately consult the index and pull back the data. That's called an index-only scan. And what you can do is add additional columns to that index. So if you have, this may bring up the case of where you may want to use a multi-column, like if you're putting account ID and processed at date time, you could have that in your multi-column index. And if all you're asking for is those pieces of data, you can pull them over in index-only scan. And if you're using later versions of Postgres, there's also the include statement. So what that means is you can actually, to your index structure, add additional columns to be able to get more index-only scans. So those columns will be pulled over with your index-only scan.
And that's a huge performance thing, especially I see this a lot in Rails where people just say, give me the entire record. Only select the fields that you're trying to work with. And if you've got something where you're selecting, let's say you've got an endpoint that gets hit 1 million times a day and it uses 4 of 53 fields out of a record, put those 4 records in an index and only select those 4 fields in an index and only select those 4 fields. That massive performance improvements just for thinking about things like that.
And you can, and you know, like, again, like trying to put an index on every field, you don't want to put your whole table in these includes, because then you're not helping. But there's a balance.
Your index becomes the heap.
Exactly. You know, you're doing double time, and then your boss is coming to you, why are we using so much space in the database? You know, so it's a balance, but for certain use cases, they can grant you, you know, huge performance improvements.
Yeah, like if I had a query that was running 20 times a day and it used 5 fields, I wouldn't bother to index those 5 fields. It's not running enough. But if I have one that's running 1 million times a day, that's probably worth an index. Yeah. And, you know, it just depends on, like I said, you know, just check out, at least in Postgres, check out your PG stat statements and you'll know what is taking the most database time. Or if you know something's particularly slow, you know, you can just use explain to analyze what's going on and figure out how to improve it. If you like this clip and want to watch another one, you can click right here. Or if you want to watch the full video, you can click here.